Hi guys. So today we're going to start our unit on one variable statistics. Okay, so when we're talking about statistics, stats is a science. It's a science of collecting, organizing, and analyzing data. So when we talk about that, we have two main types of data, categorical data and quantitative data. So think about if you were to create a survey of categorical data. So favorite type of shoe, maybe favorite brand, that would probably be easier. Or another category, hair color, eye color. So those are all categorical types of data. So hair color. Let's see, maybe favorite band. Okay, so that's all categorical data. Now, quantitative data, think quantity or how many. Okay, so within quantitative data, we have two types. We have discrete data and continuous data. And we've talked about what these graphs look like before. Discrete data, remember, those are the discrete, those individual points on a graph. Whereas continuous is usually where we connect the points. So discrete, it has individual points. So when I'm thinking of discrete, I'm thinking number of siblings. That's an example of discrete data. You are not going to have half of a sibling. Yes, they might be your half brother or half sister, but they're still a person, okay? So there's a whole sibling. So number of siblings. Let's see, what's something else? Number of shoes. Yes, I will not admit how many shoes I actually own. So those are both types of discrete data. Again, I guess I shouldn't, maybe number of shoes, number of pairs of shoes. You could really do that either way. But again, it's not a partial shoe. Your dog ate it, so you threw it away. Now, continuous data. Continuous data is measurable. It is measurable data. So think about things that we can measure. What are some things that we can measure? Distance. We can measure things in weight. Let's see. Distance, feet, weight, pounds. What are some other ways? Oh, let's see. Time. Minutes, hours, things like that. So continuous data is things that are measurable. I can get pretty precise with those measurements. Whereas that discrete data, it's only whole numbers. So, let's come over here to our left side. When is it most useful to use a dot plot? So think about it. A dot plot. Let's review. A dot plot uses a number line. So can I put hair color on a number line or a favorite band? No, that does not work. Discrete, number of siblings. Okay. 0, 1, 2, 17, whatever. So yes, those we can place on a number line. Continuous data, distance, 1 foot, 2 foot, sure, but what if we're breaking it down into inches and centimeters? That could be really difficult to put on a number line and a lot of tick marks. So the best way to use a dot plot is when you're using discrete data. Also, think about using a dot plot when you've done in the past. It's really going to be very helpful if you have a smaller set of data. Think about it. If you've got a data set that has 50 or 100 inputs, oh my gosh, that is going to be totally obnoxious putting that on a dot plot. So we want a smaller set of data, usually less than or equal to 20 items or 20 people being surveyed. So a smaller set of data for a dot plot. So over Remind, I asked you guys, hey, can you go ahead and send me some numbers 1 through 9 so that we can make a dot plot. So this is the data that I recorded. Again, feel free to pause the video at any time so that you can copy this down. So let's go ahead and we're going to use a frequency table to track our data. So every time that frequency, let's review frequency. Hopefully, if you don't remember, frequency just tells us how many of something we have. So I'm going to go through, and to keep track, I just put a tick mark every time I have one of those numbers. So I have a 4, a 9, a 1. I'm going to go ahead and pause the video so I don't waste time. So you guys go ahead and fill in your frequency table and press play when you're ready. Okay, so I went ahead and filled in my frequency table. And I always want to double check. So I had 13, 14, 15, 16, 17, 18, 19, 20, 21, 23 of you respond. So there should be 23 tick marks. 1, 2, 3, 8, 1, 2, 23, perfect. Just to make sure that I didn't miss any. So when we go to record our data on a dot plot, I've set up my number line. So I had 1 through 9, and I'm just going to go ahead and create my dot plot. Now, dot plots, I have seen them using dots, and I have also seen them using little X's. I don't care. I've seen both ways. I just want you to use whatever you like best. So since it's called a dot plot, I'm going to go ahead and use dots, but again, you do whatever you like. So I had 1, 1, 1, 2, 6 threes, 3 fours. I'm going to try and keep these kind of parallel to one another. Helps to really see the shape a little bit better. 2 5s, 3 6s, 4 7s, 2 8s, and 1 9. Beautiful. All right, so we have our dot plot. I numbered my number line numbers because, well, that's what we picked. Now, when you're comparing data distributions, we look at the shape. So if something has a nice symmetrical shape, all right, our majority of our data is in the middle. We have a little on both sides. Now, if your data is skewed right, so look at where's the majority of our data and where do we have a little bit of extra data? On the right side. So it's skewed right. Does that make sense, hopefully? So same thing. If you're looking at where's the majority of your data, where's there some excess? If it's on the left, it's skewed left. Below this, it also has a diagram of a box plot, what that looks like when skewed right or skewed left. So I usually pay attention to the middle 50% of my data. Okay, so look, when it's nice and tightly clustered, that means there's a bunch of data in there. Same amount of data, on both sides, it's just tightly together. Like here we have more 3s and 4s, so that's going to put more tightly knit, and then it'll spread out a little bit more over here. If we were to describe this data, how exactly would you describe that? I'm going to say I don't really see. I would not call that anything skewed right or left because it's kind of a hot mess. Now, if we were to do another dot plot, and maybe have all 100 students, which again, then it would not be a good way to use a dot plot because there's just too much data, then that would probably give either a more symmetrical or a more skewed right or skewed left. When you're looking at a smaller set of data, it's a little bit harder to see. Okay, I think that's good enough for now. Go ahead, I'm gonna stop the video and I will pick up. If you can either stop here or you can go on to finish the notes in the next video. Completely up to you.